Hello, in this video, I will show you how to build an image search engine using semantic search. But first, let's take a look at the final product. I have integrated the API of the image search engine with this custom version of ChatGPT. Here, we can request a very specific picture. For example, here is a very detailed description. Misty forest at dawn, sunlight piercing through the dense trees. Now the program is matching the description with thousands of pictures, maybe like these ones. Let's see the results. It indeed found the most suitable photos according to our requirements. If you like, you can try it out using the public link in the video description below. Now, let's explain how it works and its potentials. If you are familiar with Midjourney or Stable Diffusion, you might have noticed that AI can understand to some extent what a picture is describing. It can convert a user's description into an image, and this process can be reversed from image to description. And this is what I did in this project. Currently, image search engines rely on manually labeled information, such as titles, keywords, and labels. In this project, I introduce AI-generated image descriptions as another crucial attribute for image search. To test this idea and explore the potential of semantic image search, I designed this project which only utilizes two kinds of inputs, the image itself and its title. These inputs are typically insufficient for common image search engines. However, once powered by AI models, they work well in accurately finding the most appropriate images for complex requests. In the rest of the video, I will implement this project from scratch step by step. Here is our plan. In section 1, we will cover data gathering and processing. You will learn how to build a vector database for semantic search. In section 2, we will make our service public. You will discover how to use AWS Lambda, S3, API Gateway, and GPTs to publish your own service. To simplify the process, I have split each section into 4 tasks that are clearer and more achievable. Let's tackle them one by one. By the way, I have opened all the source code on GitHub. Check it and feel free to use them for your own project. Now let's see how to download the images we need. First, we need the code in GitHub. Please download it to your local computer. And after downloading it, there is a download image Python script here. Let's open it. And you can find out we use a Pixel API. Let's look at some documents. There are 3 photo-related API in this document: search for photos, curated photos, and get a photo. As we are aiming at high-quality photos with an even distribution across categories, so I choose this search for photos API because the results returned are high quality, well rated, and I can control the keywords and the download amount to manage the category distribution of my image in database. Now onto the code segment. This API requires user to provide a keyword as its parameter, along with a page index and the number of images per page. Here are all the keywords I am using to ensure a varied category representation in the image we download. For each keyword here, we can cite the number of images to download, and it will set a download plan. To pulling all the information like downloading URLs and other basic information into a list before we download them one by one in this function. My API key has hit its limit unfortunately, so I cannot just run it, but it is pretty straightforward. Just paste your API key here, run it, and feel free to adjust the keywords and download quantities you see fit. In the second task, we will convert image into descriptions. Previously, I manually added some image and the metadata. It should exist if you run the previous script successfully. Here is what it looks. And the metadata, including ID, some URLs, and this is like a title or description that seems useful to us. But let's see the code that can convert the image to a description. This image to description Python script will help us. Let's take a look at how it works. Let me create a new file called section1 and task2.py. Okay. And first, we want the model itself. This function is calling the model here. You can see the CI is representing the library we imported. From this library, it imported the interrogator and will be finally used in this function. So those lines are configurations, and let's take a look step line by line. The model names is just name, do not need to change it. And the prompt mode is here. We want the best prompt with the highest level of accuracy. And the source path and output path, we need to modify it. Our folder is here, and this should work. Check. Download images. Yes. Images. Yes. This works. And for here, it will initialize some objects for the function to use. And I found the output folder may not exist, so we should create one if not exist. So let's write a line. It will use OS path exist and the output folder path. If it not exist, we will create a new one. make DIRs and the upload folder. Save it. And for here, we are going to call this function. The function needs some image passes. See, we will add a image. Yeah, and we will call this function. And the mode is the default mode. And we'll check the result. Now let's try to run it. My computer is using a 4090 graphic card, and it can actually every day it can process like 7,000 pictures every day. The result is a list of prompts. All you can see keywords, and the first is definitely must be the description. There is a small car. Yeah, there is a small car parked on the cobblestone road. Reasonable. Let's try another picture. Says sunset over the ocean with a boat in distance. There is both. Sunset, ocean. It could be ocean. So after seeing that, I think this model can help me, and I will extract the first as my description. Using the current code, we can process only one image, and what we need is precise all the images from source pass to the output folder. And I remember there are something we need to notice. The first is we have some already processed file. Not already. So it will take a really long time. If we stop and continue, we should skip all the processed file. And the second is data type, file type. In the source folder, we not only have image and we also have the metadata. So we want to skip metadata. Let's see how to achieve this. So first, processed file should not be should be skipped. As all the processed file, we will write down some information in the output folder path. So we just need to check what file is existing in the output folder. We can use list_dir to get all the file names, and the file names is named by the image ID. We can extract all the ID and put it in a site. So this part of code will help us to do not duplicate processing. And checking image tabs is also here. We only want the tab of the followings to be processed. And for here, we want to write something in the output folder. What I did is I just used the previous metadata and added a new attribute called prompt. And this prompt is what we have just achieved from the machine learning model. For example, this is a list prompt we are going to write down here. And that's it. Let's try if it works or not. Check it. This one. Let's see. Output description. Hey, delete it. Let's try it. Oh, it created a output description folder and oh, here is the prompt. Seems it works well. The processing is finished. Check everything looks good. After having our descriptions of images, we can work on task 3, which is encode all the descriptions into embeddings and upsert it to a vector database. Let's see how to make it. First, encode descriptions into embeddings. Then we will upsert. For here, I chose OpenAI embedding model to help me to embed my descriptions. I have also tried another machine learning model, the sentence transformer, but as our backend is Lambda, which do not support GPU computing, so I will just call the API from OpenAI and let's begin to code it. So first, this must be the call line, which calls the embedding model. And it needs a client from here. And we also need to import the OpenAI library. This line needs an API key. In this section, we will need the OpenAI API key and a Pinecone API key. This line, it needs two inputs, the text to encode and the model. The model is this one. And the text is unknown for now. The text is the description itself, so we also need to load all the files we generated previously and assign it to the text. So before here, we need to load file. To load files, we have a source path and output path here. This line will help us to read all the files in source path. So in this list, it only contains file names, not the full path. So we need to join the file name with its folder path. Let's have a try. So we have all files. Now we can read the source file. See. From the source file, we have the content, and the content will include our description. Previously, we used prompt, and the first is the description. Now let's try if this works. And into import. And for JSON, let's try it. Here is our four descriptions, so the code works well for now. We get our description and we can feed it into our OpenAI embedding model. Model and the client. And the text should be equal to the description we just generated. And the result. I have already added the OpenAI API key secretly, and we can have a try here. Embedding results. Not readable. We need to parse it. Let's try. Now it works. It's a list of float numbers, maybe double numbers, and its size is pretty long. The last is 1535, but as the first index from 0, so it's 1566. Now we can upsert it to database. To do that, I think we can create an index first in the database. Let me show you. Here is a pine call, and to create an index, we will give it name, a dimension, The name is and the dimension as we tested is, and the matrix, I will use cosine in semantic search. And the starter had a free tier, but I have already used used it out, so here I will use the serverless one. It's created. Let me show you how to upsert records to this database. So here is the name of this index. And to upsert it, we need to those two lines. And the index name is what we have here. And its API key is this one. And the core line is here. We need to upsert a vector to this vector database. So the format of this vector is like this one. So actually, it is a list of dictionaries. Its format is like this one. Let me show you in Pinecone. Check my previous database. And if you have ID value is embedding, now we need to assign those values. From the content, we can get those values. For example, ID should be from content. There is a attribute called ID. And for the values, it's the embedding itself. The embedding and the metadata. Let me copy something. Metadata is two URLs read from the content. And we get every data. And here we need to import the library. Now let's try it. Currently, the index is empty now. And let's try. It seems the ID is in int data ID. Currently, the data ID is in int type, and maybe the database requires us a string type. So let's try. And let's take a look at the database. Refresh it. Oh, great. We have our vector data successfully upserted. Now the main function is finished. What we need to do is to refine the code or adding some functions. So first, I want to keep a copy of the embeddings as each time I call the OpenAI embedding model, it costs a little bit. So keep it in my local might be a good idea if I lost them. So let me see. It's pretty straightforward. I just read the previous content and add another attribute called embedding and save it to our output file path. Let me have a try. So the output file path is the description embeddings is empty now. And if we run it, so it's saved in our local computer. The next thing I want to do is to uh, organize this code. So for here, what I did is put all the code into a class. I initialized some objects here and split it into several functions. And the last thing I did is to enable concurrency or say multi-threading. What I used is the concurrent dot filter. And firstly, I will split all the files I need to process, actually maybe a dozen of thousands files. And for here, I split it into 10 parts. And for each part, I will create a separate file processor, which is just this class, and use this separate processor to process this part of files. And it greatly improved my processing speed. Previously, we have already downloaded all the images we need, convert them into descriptions, and encode them into embeddings. Then, we created our vector database, which is ready for semantic search. In the final task of this section, we will try to test the query result. Now, let's see how to do it. First, we need the point calls query API. We need the index. And the library. For the database, and because this database only have 4 vectors, so I will use the database I previously created, which have about 70,000 vectors. And for here, we need embedding, so I will call the OpenAI embedding model. And we need some testing queries. To do that, I asked ChatGPT to generate some test cases for me. Here it is. Let's try them one by one. And it needs a query embedding. So Let's embed it. It will show top K result. Here we might try top 6 result. And from the query result, what we are interested in is their metadata. The metadata has some URLs of the images. For here are the two URLs we just saved into the database. This is what we want. If this code succeeds, we will find 6 URLs in this list. So let's try it. Yeah, great. So I don't need the image ID, so I will delete it. For this URL, let's try to open it. It works well. And considering I'm at testing for 100 times, copy and pasting the URLs to my browser for several hundreds of times is a burden for me. I'm trying to find a way that can directly show all the query results in one click. So here is a trick I find. From here, we pass our searching result into an HTML page, so it will show all the results in one click. Let's have a try. Open the local service. Yeah, here it is. So let's test all the queries one by one. First query. A snowy mountain peak under a bright blue sky with a lone eagle flying overhead. Sadly, none of the images has covered all the elements here. There are some pictures with blue sky with a lone eagle. There are some pictures with a snowy mountain peak with an eagle. Some pictures with mountain with blue sky. I guess the reason it didn't find the perfect result is I only have 60,000 images in my database. And the picture that including all the elements, all the descriptions in this query might not exist in my database. I will consider to gather more data if people like this project. So let's try the second query. An old wooden bridge crossing in a serene river, surrounded by lush green trees in spring. And here is the top 6 result. The first picture is the most similar result the vector database thinks. and this picture is the second similar. I think the first picture is a nice match. The bridge here is partially wooden and there is a serene river. There are green trees. It looks maybe spring. And from the second picture, they are missing something. The second one is not all green trees. And the third picture has green trees, but it's missing the bridge itself. And other pictures, it has stone bridge. The reason it didn't have the best performance is similar. The database only contains limited quantity of image data, and gathering more data should solve this problem. Let's continue. Let's see. A bustling city street at night, illuminated by neon signs and busy with pedestrians. I think all the pictures looks good. I think the reason it performs good is when I download pictures, I have keywords of neon lights and neon signs. So there should be many pictures related to this description. And this query result may stand for the performance if there are enough pictures in the database. We will not go through all the queries in this video, but testing is pretty beneficial in this project. For example, you might notice our embedding is not only from the AI-generated attribute, but also from this out attribute. This out attribute is a description of something like a title I get from the metadata. After a dozens of testing, I found adding this out attribute will increase the performance a little bit, but give it too much weight will make the result misleading. In these few lines of code, it says the out attribute and the prompt attribute are trying to describe the image in its own way. One is given by human and the other is given by AI. As they are describing the same thing, I can use a weighted average as a new embedding. But the weight here can only be derived from a lot of testing for the best performance. Now, we have finished all the tasks in section 1. We created our semantic database and tested its query quality. In the next video, I will introduce section 2, where we will introduce how to use Lambda as backend and create an API and expose the API to GPT action. Thanks for watching.